this new discovery will be able to probe mathematics faster than humans. And if that's the case, we will be able to execute our mission, if we can leverage it, faster. And we think that our mission is the best hope to avoiding an apocalyptic socio-political, catastrophe of mankind, because the old paradigm of materialism, which is an ancient Greek mysticism, by the way, that is not a legitimately realistic philosophy anymore, and it's harmful in some ways, because some people use materialism as an excuse to eat, drink, and be merry, because tomorrow you die, and so there's no meaning to anything, and so just do it and screw everybody else, right? That is how some people react to the philosophy.
Imagine spending an hour with the world's greatest traders. Imagine learning from their experiences, their successes, and their failures. Imagine no more. Welcome to Top Traders Unplugged, the place where you can learn from the best hedge fund managers in the world so you can take your manager due diligence or investment career to the next level. Before we begin today's conversation, remember to keep two things in mind. All the discussion we will have about investment performance is about the past, and past performance does not guarantee or even infer anything about future performance. Also understand that there's a significant risk of financial loss with all investment strategies, and you need to request and understand the specific risks from the investment manager about their product before you make investment decisions. Here's your host, veteran hedge fund manager, Niels Larsen.
Welcome back to another conversation in our collection of podcast series that focuses on markets and investing from a number of different and fascinating perspectives. The father of quantum physics, Max Planck, famously said, "When you change the way you look at things, the things you look at change." And for anyone that has made a long-term living from markets, that quote may resonate. You see, the investment and trading world is filled with big personalities that are often battling out dogmatic perspectives. It is also filled with an abundance of brilliant and curious minds that are open to expanding their horizons. In our Galactic macro series, we seek to open the boundaries of what is possible. We do this by drawing from experts working at the bleeding edge of technology, science, environment, global conflict, exopolitics, exploration of outer space and inner space, and consciousness. A core theme that spans many of the conversations involves the growing government revelations regarding non-human intelligence from advanced civilizations. This core theme is fundamentally important because it weaves every other topic into its fold. You'll likely have more questions than answers after tuning into this series, but it's guaranteed that you will have changed the way you look at things, and thus the things you look at will also have changed. And with that, please enjoy today's episode hosted by David Dole.
Klee Irwin, pleasure to have you here on the show.
I appreciate it. I've been looking forward to it.
Likewise. So for the audience listening, I've been stalking Klee for several months, and fortunately, through a network of friends, we were able to connect. And I'm thrilled to have Klee here on the show with us because I'm fascinated by what's going on in the realm of quantum physics and challenged as a layman trying to understand what's going on. And I believe that Klee has a unique gift, not only for explaining it, but also for the direction that he's taking the field. And so, Klee, again, very excited to have you here. And we're going to jump right into this so that we can unpack these things. This is not a simple conversation, even though you'll simplify it for us. Let's start with perhaps a quasi-provocative question.
Which is good because we work with quasi-crystal math, so I love the phrase.
Perfect. Why should people care about quantum physics?
Two big reasons. One is that quantum physics is how reality works, right? At the most irreducible levels. And when you understand how reality works, you get a lot of benefits, such as iPhones. I love my iPhone. Without quantum mechanics, we would not have been able to enjoy the technologies that go into an iPhone. I also love Netflix, and I love, all of the other things that quantum mechanics brings us. I love large language models like GPT-4. Without quantum mechanics, that would be impossible. And then the second major reason is for those who care about the deeper questions. What is reality made of, right? Are particles in space-time fundamental, or are they emergent and secondary, right? For example, an atom is not fundamental. It is emergent or secondary to more fundamental things under it, like quarks and protons and electrons. So these questions about the nature of reality can go even deeper than is space and time and energy fundamental, or is there something more like information under the hood that is fundamental? But some of the deeper questions at that most foundational level go to, well, why is it in the double-slit experiment, when we have knowledge, right, awareness of the measurement data, that it mysteriously changes the behavior of the physical system itself? It's such a problem that physicists call it the measurement problem, and it has never really been solved at a consensus level. So those are all the juicy questions that kind of are at the nexus of things like, what the heck is consciousness? I mean, literally as an English word, what does it even mean technically? Because experts at universities cannot agree on what that word even means, right? And why would something related to consciousness have anything to do with quantum mechanics in the measurement problem, right? Those are deep and juicy questions, at the nexus of what it means to be human and deal with trees of meaning, right? The way GPT-4 does, right? It's these hierarchical trees of emergent meaning, right? And that's how we think. We humans think in these exact same hierarchical trees of meaning, language theoretically. And what would all of that, right, consciousness and meaning, have to do with some beyond quantum mechanics, mathematical physics that explains physicality better, right, than our existing placeholder theories?
Absolutely. And so, I think one of the things that is misunderstood by the general populace, and you nailed it right off the bat, talking about, iPhones. And most people have this perception that quantum computing, quantum technology is something that's on the way rather than it's in use currently, right? They don't understand that quantum mechanics is being used currently. For those unfamiliar with the slit experiment, perhaps just a quick explanation of what that is, because that was one of the early discoveries with quantum mechanics and is very unique to its capabilities and its mysteries.
Yeah, I'll even go further and I'll relate it to something that John Wheeler, who's the guy who coined the phrase black hole, thought about a large-scale version of this double-slit experiment and how this relates to consciousness and backwards in time, or retro-causality. So, first of all, the quantum formalism, which I call the modern version of quantum mechanics, which came after Max Planck and Einstein and Bohr's work. The real modern version of quantum mechanics was first discovered by Heisenberg in the matrix approach to quantum mechanics in the 1920s. And then about a year later, Erwin Schrödinger came up with his version called the wave function approach. And then a little bit later, Paul Dirac found that the two approaches were equivalent. So the weird thing about that modern version of quantum mechanics is it doesn't tell you what measurement means. It doesn't tell you that the measurement will change the physical behavior of the system as it does. Just the knowledge of the measurement changes it. It doesn't predict any of that. The double-slit experiment and this weird measurement problem is what we call empirical, which means we just observe it to happen. So it just seems to be true, but we don't have a theory that tells us that it was going to happen or why it happens. In other words, quantum mechanics does not tell you that the physical behavior of a system is going to change just because somebody has awareness of the measurement data. You could say it this way. Quantum mechanics does not predict the collapse of the wave function. That is an empirical bolt-on that you're forced to deal with that's not explained by the quantum formalism. So let's get into the explanation of the double slit, as you asked. We can't really see these particles, right? We can't really fully see an electron. There's visual interpolation concepts and computers that can take data and render something, and we can say, oh, we're looking at an electron, but not really. So because we can't see it, we don't fully know a lot about it, right? For example, we don't really know if it's more of a wave or is it more of a particle? And if it's a particle, how do we define the word particle? Does that mean it's something like a dimensionless point, infinitely small, or is it more like a little ball that has a finite size, right? So what quantum mechanics job is it's to say, hey, if you plug in what you do know about a system, whether it's the universe or just one particle, you tell us a bunch of information about it. That is, plug that into the equation, and then the other values in the equation, like these constants, like Planck's constant, all of those crank out on the right side of the equation an answer that we can say is the solution to that equation that generates a probability distribution. So, for example, let's say that I know that at right now this electron is moving at a velocity in this direction, and I know various things about it, like its energy, and then I can plug all that information that I've observed into this wave function or Heisenberg's matrix approach, and I can basically say, okay, now do your job. Tell me, for example, what's the probability if it was here when I plugged the info in that 1 second later it's going to be here or here or here or here or here, and the quantum formalism would generate a probability distribution, and it would say, okay, David, well, there's a 13% chance it'll be here, right, in this state with this energy and whatnot, and there's like a 1% chance it'll be here, and so on and so on. So that's called the probability distribution. So if you were to fire that electron through a little barrier, then you cut two slits in the barrier, and you kind of fire the electron right down the middle between the two slits, you could say that there's a 50% chance it'll veer off to the left and go through the left slit, or 50% chance to veer off to the right and go to the right slit. So that means you'd say, well, there's a 50-50 chance it goes either way. Now that would be classic Newtonian physics. But in the quantum formalism, it seems that the electron might be going through both slits at the same time. And when I say seems like, okay, it's because when we do that with lots of electrons, we see this pattern on a screen on the other side of the two slits where the electrons would like collide with the screen and make an electromagnetic signature that you could measure, right? So anyway, what we see is when we don't have knowledge of what slit it went through, right? Because you have to be looking at it or have a detector that can give you information and give you knowledge. So when we don't have access to knowledge because there's no detector there, we see that the pattern that builds up on the screen when we're firing lots of electrons is the classic interference pattern, as though it was waves going through the slits, right? Because if in the water, right, if you tap the water and then a wave radiates out and then there were two slits, well, of course, the wave, the little circular rings are going to go through both slits, right, at the same time. But if it was a particle radiating out, right, from when you tap the water, then it would only go through one or the other, right, or neither. So anyway, so this interference pattern shows up, implying that it's going through both slits like a wave, that all the particles are going through both slits like a wave, and then that wave on the other side of the barrier with the slits, and between that and the screen, those waves, right, are interfering with each other. It's very, very abstract, right? Because waves of what? Probability, or literally the particles are waves. And this is what everybody argues about in quantum mechanics. Some people say, well, no, it's literally a wave. Some people say it switches between a particle and a wave, and they argue because the quantum formalism doesn't answer these things. Now, that's the case when nobody can have knowledge of what slit it goes through. But then let's say, all right, using your name, right, David, that, all right, well, let's say we rig it up so David can have knowledge. Either with his eyes, he can somehow see, detect which slit, or we put a little device that detects that the electron went through this or that of the two slits. So then David can get access to the knowledge. Now, when he can get access to the knowledge, right, it's as though the universe knows that he can get access to the knowledge, and it changes its behavior. It goes back to the interference pattern just disappears, as though now the particles are not acting like a wave, or that there are two particles for every one, where one goes through one slit and one goes through the other. Now it goes back to acting totally the opposite, as though the universe knows when somebody is able to have knowledge of what just happened. So that's why we call it, physicists at least call it, the measurement problem. Problem because how in the heck would something as trivial as the emergent consciousness of some mammal, like a human, have anything to do with something so down to the bedrock of the ground of mathematical physics? Why would those two things have anything remotely to do with one another? That's a problem, right, for most people. And that's called the measurement problem. And it's never been solved to this day. And it remains one of the most contentious areas of physics. For example, you will definitely see posts on this on this session that we're doing of people saying that I'm a quack and a pseudoscientist for even mentioning the measurement problem in the way that I described it, for even saying the word consciousness in the context of figuring out science and mathematical physics, because it's super emotional and charged. And materialists who have a philosophy of materialism that consciousness is trivial at the level of what we're talking about, they're downright passionate, almost religious about their view. And so they can be very spicy, to say the least, right? And so for me, I think we should just tone down the religion, whether it's the philosophy of materialism or some other philosophy, and just kind of think rationally and consider any plausible idea. Yeah, so sorry to go on about that. Now, John Wheeler, I promised I would tell you about retrocausality. So John Wheeler, he's a titan of modern physics. He was kind of daydreaming at night and looking up at the stars and thinking about a large-scale version of the double-slit experiment. So imagine he was looking at the closest star, Alpha Centauri, where a photon would leave the star and 4 years later it would hit your eyes or hit a telescope here on Earth. Now, remember how I described the double-slit experiment, right? We have something that shoots an electron, and then it goes through this barrier in one of the two slits, and then it passes through some space until it hits a screen on the other side. So let John Wheeler's eyeballs, the thing that's the screen that's going to receive a photon from Alpha Centauri, the closest star. And then we're going to make, this is his thought experiment, not mine. So then he says, all right, the equivalent of the right slit or the left slit, where you kind of have it centered so there's an equal probability to go through either side, that can easily be something like a planet or any gravitational mass between Alpha Centauri, 4 light years away, and Earth, just right in the middle, 2 light years away from Earth, 2 light years away from that closest star, such that a photon or electron or anything emitted from that star that can hit Earth, that can hit John Wheeler's eye, that will be lensed around this gravitational mass like a planet, and it's just going to go that way, right? The gravity will bend it around, bend it like Beckham for any soccer fans, right? And it'll hit John Wheeler, and it'll hit a detector like a pair of eyeballs or two telescopes on Earth in either one or the other, right? And so John Wheeler knew that the scale of that is exactly the same form and would give the same results as a small scale version of it in a lab, the normal double slit. But what it opened up his mind to realize is the fact that he's back on Earth, let's say in the year, 1980, right? Maybe that's when he first thought about something like this. So let's say he's daydreaming on that thought experiment in 1980, and these photons are hitting his eyes, and he's imagining that if there were a gravitational mass between Alpha Centauri and him, he knows that the particle, because he's observing, would have had to have made its decision, right, to go through the right side of the gravitational lensing or the left side 2 years into the past. But if he wasn't observing, then it would go through both slits at the same time in that weird quantum superposition idea. It's an exact replica, just at scale, of the double slit. But the interesting thing is it forced him to deduce, just by rationale, that, oh my God, that means I forced it to take it's called the which way path, to go through this path or this path, right, on the 50-50, bend. I forced that to occur 2 years ago, and because it'll take 2 years, right, to come to me. So I hope that holds, that language holds up, and I didn't mutilate it too badly. That this made him realize, oh, quantum mechanics is retrocausal. So I changed the physical behavior of the system 2 years in the past, in 1978, by my free will choice to observe up here in the future in 1980, right? In this example. And furthermore, the mathematics of quantum mechanics in its most raw and unapologetic form also implies retrocausality. And then experiments were done called the retrocausal quantum eraser experiment, and published. And those supported John Wheeler's conjecture that actions in the present impact events in the past, right? And obviously, according to the classic normal view, actions in the present change things in the future. But if your actions in the present are changing things in the past and the future, as experiment and the quantum math imply, now you're into the concept of feedback loops. Because if the future is changing the past and the past is, like normal, changing the future, you have a sort of guitar string or feedback loop.
This is all fascinating. And so, getting into retrocausality, when I read Michael Talbot's book, Holographic Universe, nearly 20 years ago, they touched on that. And there's been some other experiments, one of which I'll share here in a moment. But to help anchor, traders, since we've got a community of traders and investment professionals as the core audience, some of the things that will build familiarity to these concepts. So first of all, it's fascinating that the mere act of observation can change the result, right? And this has been, supported in quantum, mechanics for quite some time. And for traders, the familiarity, I'll give different examples. Anybody that spends time staring at screens of moving markets all day long, like I do, you get uncanny feelings for feeling that, a position that you're watching reacts to the fact that you just simply have the position on. I doubt there's any trader that's not had that interesting feeling. And then you have people that have tried to articulate that, famous investors like George Soros, who has the theory of reflexivity in markets, which is a very, fascinating concept and has a lot of logic to it. But one of the experiments, and I'm sure you're familiar with this because it's been done in a bunch of universities and tested all over, and this one just blew my mind. There's this experiment, and correct me, Klee, if I'm wrong as I describe it. But basically, it was testing. Imagine you take a computer and it's going to flash two random images, right? And you got to choose one, right? So let's say an ice cream cone and a hamburger, right? And it keeps mixing it up, a cat and Coca-Cola, right? So random images. And what they did was they wanted to show that could they influence the selection, right? So what they would do is they would subliminally flash faster than you would, notice consciously, but your subconscious mind would get it. And so they'd flash, let's say the hamburger first, right? And then you choose between the hamburger and the ice cream. And of course that influences and statistically shows that, you're influencing that choice and more people select the hamburger. I think everybody listening would find that logical and, pretty straightforward. And subliminal messaging is nothing new. That's been around for decades and decades. What's fascinating on the retro-causality part is they then ask themselves, could we do that in reverse? And so what I mean by that is what they did was they showed the hamburger and the ice cream, let you choose which one you want, and then flash the subliminal hamburger after you'd already chosen, and statistically showed over and over and over that it was the same. That is just, that is a complete reorientation of how we understand these things. Now, to also help the audience, because you guys have done some really fascinating work with the simulation hypothesis. So most people listening, especially because, Elon Musk and others talking about, simulation theory and are we living in the Matrix and all this stuff, that's pretty popular. Most people have kind of a base understanding of that. But you guys published a paper, I actually got it here to the side here, the self-simulation hypothesis, interpretation of quantum mechanics. And you guys published this in 2020. And this is a very unique take on this that I think is really, really worth taking a moment to unpack. So maybe if you could give the audience just a super high level of, the simulation hypothesis is generally understood amongst the public. And then let's go into you guys' work on self-simulation.
I love it. Before I do, though, you excellently explained that experiment. The guy who you might be talking about, if not, he's done some of the best experiments of that class. His name is Daryl Bem, B-E-M. He's out of Cornell, and he's published at least 9 extremely rigorous experimental papers in the peer review literature that show what you described over and over. Like one of the ones that they repeated many times would have these images that psychologists have established as kind of like scary images and non-scary images, like a child holding a puppy and then a rattlesnake lunging out at you, right? So those images for the human animal will create a galvanic skin response, like you see the scary thing and it'll have, you can't control it. It's this little thing that detectors can pick up. So anyway, then they establish a baseline where they'll just do hundreds of times of randomly showing somebody the scary pictures and the lovey-dovey pictures and just, kind of calibrate the baseline, make sure it's working, make sure the person's nervous system is responding appropriately, right, to the two types of pictures. Then they hook up the choice of which, picture to a random number generator, and they very, very carefully measure the time at which your body registers that it has experienced the scary one or the lovey-dovey one, and with absolute statistical significance, it was experimentally very, very clear that somehow the human being is able to know if it's going to be the scary image or the cute image before the random number generator even made its random choice. And there's no explanation for that other than, theories and guesses, but that's experimental empirical evidence that somehow whatever consciousness is, it as though it can interact across time. right? In that case, it's like it's getting information in the past or from the future, or its state of consciousness is changing is actually somehow interacting, right, to create the future and past. So what is emergence theory? What is the self-simulation hypothesis? And what is, quantum gravity research? So our institute is a 501c, nonprofit. And by the way, we've had to do a recent layoff in our staff because of some financial problems on my end with my money. And so it's good that this is a money show. But yeah, I'm having some cash flow problems. I'm the number one donor. Anyway, so hopefully you can post at the end for your listeners a little ask video that we made to help our nonprofit. Obviously, we send tax-deductible receipts, but we really need the help. So I formed quantum gravity research 14 years ago and have been the primary donor. So I've spent probably $15 million of my own money for the benefit of humanity to try to understand how do we synthesize quantum mechanics and general relativity and also explain why consciousness has something deep to do with the very fabric of reality. So nobody's discovered yet a theory that people agree on and that makes predictions that unifies, the theory of space and time, which is general relativity, with the best theory of everything else, which is particles, and that's quantum mechanics. And the two theories say very strongly that the other is wrong, right? General relativity says down to the core of its axioms, quantum mechanics is just wrong. And quantum mechanics says the same thing about general relativity. And yet we know that both theories are at least partly correct because they make good predictions. But we also know that there are holes and blind spots and assumptions in these theories that may not be correct. And we also know that since they both imply one another are wrong, that if they are to be unified, because in nature they're unified, the stage with which the actors called particles play out in is the stage of space-time. So it's all one system. And so there has to be a unification theory. We just haven't discovered it as humans yet. So maybe when we discover whatever the missing link is that's prevented us, and we've been looking for at least 100 years for this unification theory, maybe when we discover that, it will surprise us with a provocative answer on the measurement problem and what consciousness is and why it would be so foundational and seminal to the very nature of reality itself. So that's what quantum gravity research's mission is, to discover a mathematical first principles unification of space-time and energy, where that energy includes particles, information as in information theory, and consciousness, whatever that word means. And first principles is a tall order, because that means no hand-waving plugs, right? You can't just take a value like Planck's constant because you observe it to be true and then just plug that into a physics model or an equation without an explanation of why that number is what it is. And that's the difference between a first principles theory. By mathematical first principles, nothing is plugged, everything comes out. So then what is the self-simulation hypothesis interpretation of quantum mechanics? And what is emergence theory? So emergence theory is just an example of theories that can live inside this paper we published called the self-simulation hypothesis interpretation. And so let's get into that. So it starts with this. It starts with the question of, all right, what's reality made of? All right, quantum mechanics very strongly says if you're just strict about the math and you just get rid of all emotions and assumptions, quantum mechanics is pretty clear in saying that reality is made out of information, period. All right, what's information? All right, if you're going to think about it, you got to know what these words mean. and people can argue about the meaning of a given word. Information is meaning conveyed by symbolism. So try to come up with any possible example of information that you've ever come across, and it will be meaning conveyed by symbolism, whether that's the symbol zeros and ones and the meaning conveyed by how those are arranged into 8-bit packages called bytes, which then get arranged into higher order packages, to encode your favorite movie on a DVD. It's always English, right? A bird language, C++. Information is always meaning conveyed by symbolism. So reality is meaning conveyed by symbolism. What is a symbol and what is meaning? Well, a symbol is easy. A symbol is just anything it's literally anything that can be thought of that represents itself or something else. And it's that broad. And I don't think anybody would disagree on that definition. Okay, then what's meaning? Well, now you're getting down a slippery slope, because to define meaning, it seems that you have to know what the heck the word consciousness means. And if nobody knows what that word means, or they think they do, but they can't get a consensus, then we also don't know what the word observe, aware, meaning, thought, or any word that relates to that weird word consciousness. But we can say things about meaning. We can say meaning tends to live in hierarchical trees. Like we have the meaning of the letters of a word. And then if we organize those letters into words, we get a stratum 2 level of the words, like run and fast and dog. And we can organize those into sort of the groups, like the dog ran fast, and boom, you get an emergent level at stratum 3, and so on. So all meaning, whether C++ or bits to bytes or human languages, always, in every case, is hierarchical in a tree of thoughts. So that's what meaning is. And large language models are dealing mathematically with these trees of thought using a math called category theory, typically. Okay, fine. So reality is meaning conveyed by symbolism, and it's always hierarchical, right? Like how quarks and electrons self-organize hierarchically into atoms, and those organize into molecules like DNA and so on. And so we then say in the self-simulation hypothesis, because it's a very quantum mechanically oriented thought process, we say, all right, so quantum mechanics mathematically pretty strongly says that reality is retro and forward causal. It goes in, the causality goes in both directions, which therefore means that in principle, if reality were code theoretic, which means language theoretic. So that came out in an earlier paper called the code theoretic axiom. So language theoretic, code theoretic, and then axiom is like a scientific or mathematical starting point. You may not be able to prove that that's the case, but that's your starting assumption. So we have a starting assumption that reality is made of code or language, and we have an interpretation of quantum mechanics from the math and the experiments that things go in both directions of time. So therefore, okay, it's possible for an emergent mind-like substrate, computational mind-like substrate in the future to emerge that has the mental capacity to hold within its mind its own code of origin, its origin code. So let's do a thought experiment. Close your eyes and visualize a tic-tac-toe game board. It's just 9 squares in a 3x3 grid. And are you smart enough to play out an entire game of tic-tac-toe against yourself right in your own mind? If you're quiet and you focus, most humans can play out the entire game. It's an algorithm of tic-tac-toe, but it's a language theoretic algorithm because you have rules in tic-tac-toe that you cannot violate, but you have syntactical degrees of freedom, like all games do. So it's a code-like thing. Languages have to have syntactical freedom mixed in with their strict rules. Now, a bigger version of you could have played out a tic-tac-toe game on a 4x4 tic-tac-toe board, and so on. So imagine a mind, and we don't need to talk about what that mind might be like. Would it be a collective consciousness like the Borg in Star Trek, right? Would it be something else like a Judeo-Christian God, but one that's emergent? Would it be more like your consciousness, but just a trillion times bigger? Okay. Would it be a consciousness that can think across time instead of locally in each moment of time like ours, like a hyper-consciousness? Let's not decide. Let's just say that in principle, from what we know about the laws of physics today, there's no implication that human consciousness is the upper limit of how energy and matter can self-organize into thinking minds. And we minds can compute. We're not exactly computers, but we can compute in our mind. So a sufficiently large mind, emergent forward of us, you can think of perhaps as in our descendant lineage that speciates away from us, perhaps, and figures out how to enter into vast collective forms of consciousness. So you get this plausible idea of something called the universal pan-consciousness substrate. Many titans of physics and legit people have already written about the logic and plausibility of a pan-consciousness concept in reality. Now, for us, in the self-simulation hypothesis, we take this idea that there can be, given enough time, an emergent consciousness as a computational substrate that is sufficiently strong that it can hold within its own consciousness in the future a very simple mathematical game board, like your tic-tac-toe game board, and a fairly simple algorithm or game, if you want to call it, but these are very mathematical games. That's what we work on very technically and formally at Quantum Gravity Research, and we also simulate these simple programs in a computer to generate probability distributions of how particles can evolve together. But just grok for one moment. If that crazy idea were possible, it would be like taking something in the deep future, the vast pan-consciousness computational substrate, and its origin, a very primitive, simple program operating on a mathematical game board, but all as a thought, as information. And you take that beginning and you loop it into the end so that you can ask, well, where does that simple program live? Oh, in the mind of the emergent pan-consciousness substrate. Well, where did that emergent pan-consciousness substrate come from? Well, that's simple. The particles in the simple program self-organized into atoms and then molecules and eventually DNA and then animals and ecosystems and stock markets and this podcast and the Borg-like emergent pan-consciousness substrate. Like, you can follow it all the way through where everything on the circle has a logical explanation and there's nothing outside of the circle. And that's one of the biggest criticisms of Nick Bostrom's simulation hypothesis and all those followers like Elon Musk who recognize its plausibility, is that by the same logic that we are in a simulation, right? The probability that it's way more probable we are in a simulation than not, that same probability applies to the supposedly real world in which we are supposedly also, a simulation within, and they're the only real world. But that same logic would imply that it's almost impossible for that world, right, to be the real world. So they call that turtles all the way down, and critics of the theory don't like it because it just sort of says, that doesn't explain much because you're saying we're in the simulation, but then there's this other universe. Why aren't they in a simulation? It falls apart. With ours, it's logically consistent through and through because it has a closed, self-consistent logic. So that's the self-simulation hypothesis. Emergence theory is an example or an application or a version of one of the many different computational approaches and mathematical approaches that can live within the self-simulation hypothesis interpretation of quantum mechanics. We happen to use mathematics that will bridge us to the most powerful physics theory that mankind has, which is the standard model of particle physics, which is really an extension of quantum mechanics, and mashing that up with the particle accelerator data that comes out of CERN and everything we've learned from particle accelerators. And it's a very powerful theory, and it relates to these mathematics called Lie algebras. And so we use a Lie algebra and its root lattice, which is like a crystal, but in higher dimension, to mathematically transform or project to a lower dimension, like 3D. And we derive these mathematical objects called quasicrystals, which an example of a 2D quasicrystal would be something like a Muslim mosque, right? That mosaic pattern that's very pretty. So that's the math we use. We generate probability distributions. We're trying to stay close to, we want physical realism. So we're using the mathematics that's known, to be part of physical reality.
So a couple things too, and again, to help the audience here. So one of the ways that I think about, some of the work you guys are doing, and not to oversimplify it, is that, I think about cats and lasers, right? So, when you play with a cat and you're shooting a laser and they're seeing something, a 2D object that they're running around chasing, right? It's similar in that we have these higher dimensions, and this may explain some of the things that we see with UAPs, right? Is that you have this projection from a higher dimension, which shows up in 3D for us, that kind of blinks in and out because there's a higher dimensionality to it. So we may be the cat chasing lasers from a higher dimension, if that's a reasonable
with the UAPs are like that thing, and we're like chasing. Hey, where did it go?
So absolutely, I think there's an advanced civilization that's just playing with us and shooting lasers, and we're just silly cats chasing them. And I want to read something. There was I want to help contextualize some of this, because again, all this stuff is heavy duty stuff, and you do just such a beautiful job breaking this down and helping us digest it. And I would like to read a line that's directly out of your paper. And by the way, for everybody listening, we'll post a link to the paper and Quantum Gravity Research's website. Encourage everybody to go check it out. But I love this line that you guys have in the paper. The physics of dreams can be impeccable insofar as how light triangulates off of glasses of water, how gravity behaves, etc. More powerful minds can simulate more fine-grained physics, perhaps down to the Planck scale, as the self-simulation hypothesis predicts. This is beautiful, right? Because that's something familiar to people that I don't think people think about. We're all familiar with, of course, dreaming, but nobody stops to ponder that, hey, wow, the physics, my experience of physics in my dreams is hyper real. And I love that example that you guys use in the paper. To switch it up a moment, or to maybe kind of bridge some things together. The conversation is around artificial intelligence right now is absolutely enormous, right? Everybody's talking about AI this year. I think that's overshadowing the work and kind of the cusp of the breakthroughs where we're at in quantum physics, which is one of the key reasons I wanted you on this show, because I think everybody's just souped up on AI and they're missing, quantum physics on the other side. And then of course the convergence of these two things coming together. And I also want to make a note for the audience, because this is really important to mention. I find in conversations when you start talking about quantum physics and this elusive definition of what is consciousness, I often run into resistance, kind of like where people are like, hey, let's separate church and state here, right? And I'm like, hey, I get it. I understand that reaction. Let's set that aside. This isn't, we're not yet trying to connect, the yogis and Tibetan monks and stuff, although there's good reason to do so. But let's just go where the research takes us, right? Let's go where the research takes us. And it's unavoidable that you run into consciousness as a topic, right? And what's interesting is while you find that resistance in the conversation about quantum physics, there's less resistance to it when we talk about AI, because everybody's talking about whether or not AI is going to be, conscious. Again, whatever that definition means. So you recently shared with me, and again, I'll post this for the audience to read. You shared with me some very interesting insights with all this debacle about OpenAI, which everybody in the audience is familiar with, kind of high level what went on. Why don't you share with us some of your concerns and observations about what's going on with artificial intelligence? Because I see a problem emerging in that there's camps being divided and what people are calling kind of the accelerationists and the doomers. And I think, turning AI into a conversation of team sports is not the way to do it. I think we need to have rational conversation about risks and opportunities and trying to understand what's going on here. And you have a great grasp on that. So if you could, why don't you share with the audience what you were sharing with me just a few days back, based on what's going on at OpenAI?
Sure. So the sheer theory of special and general relativity were published, that is open sourced to the world. Once that happened, it gave mankind the ability to create nuclear warheads. Quantum mechanics was open sourced to the world, and it gave the world the capability to make military lasers that can kill people and many other weapons. So the fact is that quantum mechanics, for example, is put to good use by malicious hackers, right? Already. Quantum computers, right, can do even more damage in terms of data security and hacking. And large language models will also be able to do that, which was one of the main concerns of employees at OpenAI, in terms of this supposed letter that they sent to their board of directors warning of things. So the reason I said all of that is because the genie is out of the bottle on Einstein's theories that can lead to nuclear warheads and Schrödinger and Heisenberg's work that lead to many more technologies that can be used for harm. Similarly, the genie is already out of the bottle with Google Research's paper in 2017, Attention is All You Need, and some other breakthroughs that are also publicly available. So this genie is out of the bottle. So I really don't understand, as an experienced businessman and sociopolitical observer and scientist, I don't understand why all of this talk about being able to put the genie back in the bottle or control the genie from expanding. There are 195 countries, and in each country, there are factions and groups, right? In America, right? But in every country, there are hundreds of thousands of groups who can afford to buy some compute power and take advantage of these newer types of large language models that don't require as much compute, like the open source stuff coming out of Stanford and whatnot. I don't understand how, if you think you're going to, in one country, control one cluster of companies like Google and Microsoft and OpenAI, for example, that you're going to get that genie back in the bottle. It just feels like impractical. Again, speaking with the logistics background of a business person, it doesn't work that way. So that's my 2 cents on the ability to control it. So what we need, so then we're in a foot race. If we can't put the genie back in the bottle, you're in a foot race, right, of how quickly the groups that can exploit this new knowledge and technology for the benefit of humanity versus those who would use it to hurt their enemies or make money for themselves and so on, right? Both are going to happen. It is always the case with knowledge and technology that are used for whatever you want, and people don't want the same things. Now, if we're trying to kind of organize the biggest 800-pound gorilla risks, the two biggest immediate risks are cybersecurity and job displacement. And before we jump on the bandwagon too quickly to say that the cybersecurity issue is way bigger, okay, because it's big, right, potentially, we have to get in touch with the fact that in the history of technology, displacement of workers happens very slowly by osmosis over decades as a technology kind of matures and infiltrates into a socio-political system of the earth. This is different, right? This is unprecedented. Knowledge worker jobs are already being eliminated, and we've barely begun. And as we get into the second half of 2024, we will start to see major impacts, because it only takes a few percentage points of global average unemployment, right, to tip the scale. I mean, this is an audience that understands that kind of concept better than most audiences. So we're going to see far more than a couple points of global average job displacement. We're talking about strong double digits, and we're talking about fast as hell. This is not a technology like building a dam that takes a decade, or a nuclear power reactor, or a technology that can easily be controlled by controlling nuclear material, and trying to block those who have access to producing nuclear arms. This isn't that kind of technology. This is software at the end of the day with some hardware, but this is breakneck speed, rapid adaptation technology that will sweep the face of the earth over the next 36 months, and so radically and violently transform the socio-political distribution of wealth that we have, that has worked to create meta-stability for a long time, where people like me in the upper fraction of the 1%ers, right? We will not be able to hoard as much wealth as we have, because for our very survival, we will have, we as in the upper 1% wealth holders, okay, we will be forced to make rapid reinvention of the deployment of minimal subsidy wealth. In other words, the wealth necessary on the planet to get calories to people, for example, and internet service, right? The do or die things of life, calorie and internet. So that has to happen. And this isn't some political issue of right or left wing philosophy. This is flat out modern version of the French Revolution, right? You can keep the concentration of wealth metastable like we have in the 20th and 21st century, no problem, as long as not too many people are dying in the streets in too many countries. But you can't do it with this one that's coming. So I would say those two things have to be dealt with pretty darn quick, and they should be concerning to anybody. For us, we need access at QGR to next-gen large language model mathematics, and this is what is so exciting about this supposed leak at OpenAI, is that this new discovery will be able to probe mathematics faster than humans. And if that's the case, we will be able to execute our mission, if we can leverage it, faster. And we think that our mission is the best hope to avoiding an apocalyptic socio-political, catastrophe of mankind, because the old paradigm of materialism, which is an ancient Greek mysticism, by the way, that is not a legitimately realistic philosophy anymore, and it's harmful in some ways, because some people use materialism as an excuse to eat, drink, and be merry, because tomorrow you die, and so there's no meaning to anything, and so just do it and screw everybody else, right? That is how some people react to the philosophy.
Sure. It's fascinating. We're without a doubt, we're on the cusp of exponential change, which is, the exponential function in and of itself is the human mind has a lot of difficulty grasping that. And so as we, close this conversation out, and by the way, this is just fascinating speaking with you. I could just talk to you all day on this topic because it's fascinating, it's relevant. I feel like not enough people are paying attention to it. So I'm very grateful to have you on the show to open people's minds. We will post in the show notes, links to your site. You guys have a bunch of wonderful educational material at Quantum Gravity Research. Where can listeners, find you and your research?
So, we got a growing YouTube channel with about 250,000 followers, that you just kind of go to YouTube and enter into the search bar. You could say Quantum Gravity Research. If you can remember those 3 words, you'll find us, our channel, and you can see all our videos there. You go to our website, quantumgravityresearch.org, to see my paper, to see all of our papers. You could enter my name, Klee Irwin, and ResearchGate, and you'll see about 108, peer review papers listed there. Yeah, and then please post that ask video. It's like a 3-minute video where I'm kind of reaching out to the crowd for the very first time and just asking, at least temporarily, for a little bit of help so we can keep paying the scientists and keep plugging away, at this mission that we think will be helpful to mankind in this transitional experimental hour that we're going through.
Absolutely. Well, Klee, thank you so much for participating with us today and joining us on the show. We will certainly share that information with folks. You guys are doing meaningful work. I think you guys are absolutely at the cutting edge, and I hope this show stimulates a lot of curiosity and questions amongst folks. And we wish you tremendous success in furthering your mission, and you can certainly count on me at a minimum paying close attention to you guys' developments. Klee Irwin, thank you for being with us. Niels, back over to you, sir.
Thank you so much, Klee and David, for a insightful conversation, to say the least. If you're feeling disoriented, or as Klee described it after the show, punch drunk, you're not alone. Our understanding of the world is changing quickly, and with it, our understanding of reality itself. Humanity itself stands on the cusp of a unified theory between general relativity and quantum mechanics, and the results of this unification promise an acceleration in technological breakthroughs that are difficult to project. The way that time works, for example, is being turned on its head in what is described as retro-causality. In other words, the present or future can be proven to change the past. Wow, even without grasping each concept presented in this conversation, one thing is clear. Technological progress from AI to quantum computing is hitting an exponential curve faster than even the best experts previously predicted. There will be risks and opportunity that arise in a blink of an eye. Is humanity up for the challenge? It seems, pun intended, only if we make a quantum leap to embrace what lies ahead. That is it for today. Make sure you go and follow Klee's and David's work, as well as Klee's Ask video that we posted in the show notes, because as you can tell from today's conversation, there are many ways to look at things, and sometimes we need to change our worldview, and we certainly look forward to challenging your worldview as our series continue. From David and me, thanks ever so much for listening. We look forward to being back with you on the next episode. And in the meantime, take care of yourself and take care of each other.
Thanks for listening to Top Traders Unplugged. If you feel you learned something of value from today's episode, the best way to stay updated is to go on over to iTunes and subscribe to the show so that you'll be sure to get all the new episodes as they're released. We have some amazing guests lined up for you, and to ensure our show continues to grow, please leave us an honest rating and review in iTunes. It only takes a minute, and it's the best way to show us you love the podcast. We'll see you next time on Top Traders Unplugged.